Now new topic, algebra of two functions. Say f is a function from x to r and g is a function from x to r. So here in both functions domain is x, codomain is r. These are any two real functions where x is, this domain is a subset of r, means domain contains only real numbers. Then we define a new function f plus g. Now it's a new function, means new machine whose domain will be x, common. See here f and g both have domain x, so f plus g will have also domain x, x to r, same. And its working is by f plus g of x. This is not into x. F plus g is a machine. In this machine I am putting x, means image of x under f plus g is f of x plus g of x. So image of x under sum is sum of their individual images. Similarly, f minus g, this function obtained by difference of two functions f and g. So f minus g, it is also from x to r. This is a new function obtained by difference of two functions, and it is defined by when f minus g in this machine, if you keep x, then f minus g of x is f of x minus g of x. Image of x under difference of two functions is equal to difference of their individual images. Similarly, function obtained by product of two functions. Here also x to r. So everywhere we are taking x to r. F is from x to r, g is from x to r. So f plus g, f minus g, f into g is also from x to r. And f into g of x equal to fx into gx. Image of x under product of two functions is equal to product of their individual images. Then quotient of two functions, f upon g. So here domain, it will not be whole x, as we took here x, x, x. Similarly here we are not taking x, because when f upon g will work on x, its working way is, it is equal to fx upon gx. This is defined if denominator is non-zero. If any x for which gx is 0, then this is not defined. So if any x whose image under g is 0, then this x should not be taken here in this machine. Here those x are not allowed for which gx is 0. That's why those x we are excluding from set x. That's why here domain is not whole x which we have taken in these three functions, but here from x we are excluding something which is problem. So problem is removed. Codomain is r, and defined by f upon g of x is fx upon gx. Now question based on this definition, algebra of two functions. Let f and g both are from r to r be defined respectively by fx is x plus 1, gx is 2x minus 3. Find f plus g, f minus g, f into g and f upon g. See, first of all we find f plus g. f plus g. See, f is from x to r, g is from x to r, so f plus g is also from x to r. Here f is from r to r, g is also from r to r, so f plus g will be also from r to r. And this is the way of working. So for all x belonging to r, f plus g of x for all x belonging to domain, f plus g of x equal to, by this definition, fx plus gx. Now putting values, fx is x plus 1, gx is 2x minus 3. So this is 3x minus 2. So here f plus g of x is 3x minus 2. This is the working style of function obtained by sum of two functions. Second, so it was application of this statement. Now application of this statement. Difference of two functions, f minus g. It is also from x to r. F is from x to r, g is from x to r, so f into g is also from x to r. Here in place of x, r is given. So f is from r to r, g is from r to r, so f minus g is also from r to r. Now, by this definition, for all x belonging to domain, f minus g of x equal to fx minus gx. fx is x plus 1 minus gx is 2x minus 3. So this is x minus 2x is minus x, 1 plus 3, that is plus 4. So this is 4 minus x. Therefore, f minus g of x equal to 4 minus x. Now, we find product of two functions, f into g. Again, it is from x to r. So here it is from r to r. Here domain is r, because in f and g domain is r, so we keep same. So here for all x belonging to domain, f into g of x equal to fx into gx. f into g of x is fx into gx. fx is x plus 1, gx is 2x minus 3. So this is 2x into x, 2x square, minus 3x plus 2x, that is minus x, minus 3. So f into g of x is 2x square minus x minus 3. So this is formula for function f into g of x. Now fourth function. So here domain is not the same which we have taken in f plus g, f into g and f minus g. We have to exclude those numbers for which gx is 0. So let us check here. Gx equal to 0. We solve this equation that for which value of x gx is 0. So gx is 0, that means 2x minus 3 is 0. 2x minus 3 is 0. 2x minus 3 is 0, double implies x is 3 by 2. So if x is 3 by 2, if you put here 3 by 2, then g of 3 by 2 is 0. So g of 3 by 2 is 0. So if we keep here 3 by 2, then g of 3 by 2 it gives 0. So there will be problem. So we should not take x equal to 3 by 2 in domain. So we exclude those x for which gx is 0. So domain of, therefore domain of f upon g is set of all real numbers, here x minus, here our x is r is in place of x, so r minus those x for which gx is 0, that is from r. See, domain is x minus those x for which gx is 0, and gx is 0 for x equal to 3 by 2. So from this we are excluding 3 by 2. So this is domain of f upon g. So f upon g, it can be defined as domain is r minus 3 by 2. This is domain, this is codomain, and for all x belonging to its domain, f upon g of x is fx upon gx, that is, so application of this formula. So fx is x plus 1, gx is 2x minus 3, therefore f upon g of x is x plus 1 upon 2x minus 3. This is quotient of two functions. So this is about algebra of two functions. So here relation f, see, word is relation. Relation f is defined by fx equal to x square. If x is from closed interval 0 to 3 and fx equal to 3x if x is from closed interval 3 to 10. The relation g is defined by gx equal to x square, where x is from 0 to 2 and gx is 3x if x belongs to closed interval 2 to 10. Show that f is a function and g is not a function. Say, look here. Here, if you check, let us check domain of f. What is domain of f? If x is from 0 to 3, closed interval 0 to 3, union closed interval 3 to 10. If x is from this interval, fx, image of x under f is x square, and if x is from this interval, image of x is 3x. So domain of f is 0 to 10. Now look here. If we take any number from this interval, then every number has one and only one image. No any number has more than two images. Say if you take here 3, say here 3 is common in both. If you put here 3, so 3 square is 9. And by this formula, f of 3 is 3 into 3, 9. So image of 3 is 9. Whether you calculate by this formula or by this formula, because 3 is common in both intervals. So 3 can be taken in this formula as well as in this formula. But value is same. and except 3, if you select any number from this interval, then every number has unique image. So we can say that for every x belonging to 0 to 10, image of x under f is unique. No any x has more than one images. Every x has one and only one output. Therefore, f is a function. Now let us discuss G. See what is happening here. Domain of G, it is close interval 0 to 2 union close interval 2 to 10. If x is from this interval, its image is x square. If x is from this interval, its image is 3x. And you can see that here 2 is common in both part. Their union is 0 to 10. This is domain of G. Now see, we are taking this common number, putting in this machine. Here G of 2 is in this interval. So G of 2 is 2 square equal to 4, because 2 is in this interval. 2 is also in this interval. So G of 2 as well as, now by second formula, G of 2 is 3 into 2, that is 6. That means 2 has 2 images. Image of 2 is 4, image of 2 is 6. Under G, 2 has 2 images. And if every element of domain has one and only one image, then that relation is function. But if you find at least an element which has no unique image, means it has more than one image, so such a relation is not a function. So here there exists 2 in domain which has more than one images. 2 has no unique image. Therefore, G is not a function. F is a function. G is not a function because of only 2. Problem is only at 2. And definition is that every element of domain must have one and only one image, but here there exists 2 which has more than 2 images. So it's not a function. Now in this question, see, F is given in set form, set of order pairs 1 1, 2 3, 0 comma minus 1, minus 1 comma minus 2. Be a function from Z to Z. F is a function from Z to Z defined by this formula. So here function is given in formula form as well as in set form. For some integers a and b, determine a, b. That is the question. Say here 1 1 belongs to F and 2 3 belongs to F. I am taking 2 elements. Instead of 1 1 and 2 3, you can take 2 3 0 minus 1. You can take any 2. Only 2 elements. help of two elements in calculation is sufficient to get value of A and B. So select any two. I am taking first two elements. 1 1 belongs to F, that means F of 1 is 1 and F of 2 is 3. Now by this formula, fx equal to ax plus b, we calculate image of 1. F of 1 is a into 1 plus b, that is a plus b, and if we put here 2, f of 2 is 2a plus b. So here by formula image of 1 is a plus b, by set image of 1 is 1. Now we are comparing these two values. Similarly we compare these two values. So from statement 1 and statement 2, from 1 and 2, a plus b is 1 and 2a plus b is 3. We solve these equations. 2a plus b is 3, a plus b is 1. Taking subtraction, this is cancelled. 2a minus a is a is 2, and putting here a 2. So b is equal to 1 minus 2. 1 minus 2 is minus 1. So therefore we have found a is 2 and b is minus 1. Now say question is, let f be the subset of z cross z, defined by, say here, f is ab comma a plus b. This is subset of z cross z. Means image of AB under F is a plus b. Is F a function from Z to Z? Justify your answer. So this means F, image of F as image of AB under F is a plus b. Say look here, if we take a and b, I am taking from set of numbers. If a is 2 and b is 3, a is 2, b is 3, that means a into b is 6, a plus into b, 2 into 3 is 6, and a plus b, that is 2 plus 3, 2 plus 3 is 5, 6, 5. It is in F. Put a is 2, b is 3, 2, 3. So 2 into 3 is 6, 2 plus 3 is 5. Now I am taking a equal to 6 and b is 1. A is 6, b is 1. So 6 into 1 is 6 and 6 plus 1 is 7. This is also in F. So it means meaning of these two statements is that f of 6 is 5, f of 6 is 5 and f of 6 is also 7. So 6 has more than 1 images. So that means if any element has more than 1 images, then it is not a function. Therefore 6 has 2 images, which is not allowed. 2 images under F. Therefore F is not a function. We can show so many counter examples to prove that this is not a function. Here if you take 4, a is 4, b is 2, so 4 into 2, 8. Image of 8 is 4 plus 2, 6. 4 into 2, 8. Image of 8 is 4 plus 2, that is 6. Then take 8 into 1. So here 8 plus 1. So image of 8 will also be 9. So as here we have maintained here 6 a common value in first place. Instead of 6, you can set so many numbers here whose images are more than 1. So many numbers having 2 images, 3 images, 4 images, so many images can be obtained. See, suppose if a is 8, b is 3, then 8 into 3, 24. 8 plus 3, 11. Now if you take a 12, b 2, so 12 into 2, 24. 12 plus 2, 40. If you take a 6, b 4, 6 into 4, 24. 6 into 4, 24. 6 plus 4, 10. Say here 24 has 3 images, not only 3, we can take more combinations. A24, B1, so 24, here this will be 25. So 24 has many images. So there are so many integers having many images. And if in any relation every element of domain has unique image, then only it is a function. But here it is not a function. Counter example is shown. Now in this question, A is set of these numbers 9, 10, 11, 12, 13. F is from A to N. A means set containing these numbers. Codomain is set of natural numbers. And this function is defined by f of n equal to the highest prime factor of n. Highest prime factor of n. Here only numbers from domain is allowed. So in domain these 5 numbers are given, so here we are allowed to put only these 5 numbers, no any more, no less. So here we can take n equal to 9, we can take n equal to 10, we can take n equal to 11, n equal to 12, n equal to 13. We find images of all the numbers belonging to domain. Now f of 9 means highest prime factor of 9. See prime factors of 9. If you check factors of 9, then 1, 3, 9. There are 3 factors. And which is prime? Only 3 is prime. So f of 9 is only 3. F of 10. Highest prime factor of 10. 10 has 2 prime factors, 2 and 5. And which is highest? Highest is 5. F of 11. Highest prime factor of 11 itself. 11 is a factor of 11 and it is highest prime factor. F of 12. Factors of 12, 1, 2, 3, 6, 12. Among which 2 and 3 are prime. And highest is 3. F of 13. So 13 itself is prime factor and it is highest. So these are images. So range of this function is 3, 5, 11, 3, already taken 3. So do not repeat 3 again. 13. So this is range of this function.